Okay, so here goes nothing. We are in 3.1.2. My hope is that we get through the first few problems even though I'm not here today, and that way we can continue with the next skills tomorrow, and we'll see. I'll tell you this up front, the end of class period, please check in as a class and see how far everyone's gotten. If you kind of listen around and all the groups were done and you're the only group that hasn't, I just ask you to watch the rest of the videos tonight, so that way we can continue. Obviously, if you get to the end of the class period and everyone's like, oh, we only got the first two, then so be it. We'll pick up wherever we leave off. My recommendation for these, I will start each problem, but I encourage you to pause at part way. I might guide you as to when that might be after laying the introduction, so that you can then work on this problem on your own for a little bit, but be smart. That doesn't mean I'm going to take 20 minutes and not accomplish anything, but you know, I'm not going to also give in and just watch the video right away either. So just kind of, you know, your advanced students, you know how much you can struggle, you know kind of the pacing that we do in class. So just kind of keep that in mind. And then obviously if you're working as a group and you get a solution, go ahead and just check it real quick and move on to the next part. So that's the goal here today. So starting us off, we're in 3.1.2. Last Friday we started talking about area models, last Thursday, Friday actually, and today we're going to be introducing tree diagrams. Tree diagrams are just another way that we can represent our information, and personally I use them quite a bit because in certain situations we have to use a tree diagram, and we'll see how that comes into play later on in this lesson. So when we start off in 3.12, it tells us that our teacher challenges you to a spinner game. You spin 2 spinners with the probabilities listed at right. The first letter comes from spinner 1, this is spinner 1, and the second letter from spinner 2. If the letters can form a 2-letter English word, you win. Otherwise, your teacher wins. So we have 2 separate spinners right here. Sorry, I just kind of bumped my camera right there. We have 2 separate spinners that we're using, and we have possible outcomes based on the letter that we get from spinner 1 and the letter that we get from spinner 2. Just to go through our questions real quick, part A asks if the outcomes are independent of spinner 1 and 2. So I want you to think about, we talked briefly about independent and dependent. The key idea there is, does what you get in spinner 1 change what you will get in spinner 2? If the result of spinner 1 affects the result of spinner 2, then they will be dependent. Otherwise, the data is independent. So hopefully when we look at that right there, we recognize that regardless of what we get in spinner 1, spinner 2 does not change. T or F does not become more or less likely depending on the first letter we get. So these are in fact independent outcomes. Now in part B, they ask us to make a probability area model of the sample space. That is basically what we did last Thursday and Friday. You're going to have the area model, the box with the 2 side dimensions. I'm going to give you 3 hints as you're working on this. Hint 1, this 60 degrees is going to throw some of you off. My hint to you is to think about how many degrees are in an entire circle. I'll say that again. How many degrees are in an entire circle? That should help you figure out what portion each of these letters is. Hint 2, when you go to write the side dimensions for spinner 1, so the actual values on the side of your area model, make sure to keep the denominators the same. Don't simplify your fraction. That way you can compare your results inside of your box. And finally, my last hint, as you complete your area model in part B, please go ahead and list the sample space. Doesn't explicitly ask you for that, but I would like you to do that. Please list the sample space. If you don't remember what that is, refer to the glossary of your book. So go ahead and make the area model in part B and the answer part C as well, and the solution will be posted after this.